We're talking about glycolysis, which is the first part of cellular respiration, which again, you're converting glucose into energy. And in the first part of cellular respiration, we're taking glucose and we're starting to break it down into simpler molecules. So I'll just draw a glucose. Okay, so here is our glucose molecule. I'm not expecting you guys to be able to draw a glucose molecule. But this is our principal input. This is our input to glycolysis. You put in a glucose molecule, and let's talk about the output. What do you get out of this first stage of respiration? Well, you get two pyruvate molecules. So you get two of these. So 2 times. Okay. And if you study this a little bit, you should be able to see that this molecule is just this thing sort of broken in half. Okay, this is pyruvate, and it is just a glucose molecule that has been broken in half. You also get some ATP, but you also get, and this is one of the more important ones, you get two molecules of what are called NADH. These are those high energy electron carriers that I was talking about in the previous video. These are going to be used later on to make many more ATP than you can just get from glycolysis. So let's talk about these NADH molecules. I changed glucose into its chemical formula here, and I have a representation drawn of it down here. And again, in glycolysis, we're taking this molecule and we are converting it into pyruvate. And sort of a question that always lingers in folks' minds is, well, where is the actual energy in this molecule? Where does the energy live here? And the answer to that is that the energy lives inside of the chemical bonds between these things. And if you do a little bit of chemical accounting, we can pretty quickly figure out which bond that it is in. So if we have our glucose here, C6H12O6, we have our pyruvate here, C3H4O3. If you do a little bit of algebra and you distribute the two in, you see that here are our 6 carbons, right? Because you have 2 C3s, so that gives you all 6 of these carbons. Here are our 6 oxygens, because you have O3 and you have 2 of them, so there's our 6 oxygen. But we only have 8 hydrogens on this side, and we used to have 12. So we have lost hydrogens. And why is that? Why did we lose these hydrogens? How does that give us energy? Well, like I said previously, the energy of this molecule is stored inside of its chemical bonds. And what winds up happening is you remove some of those bonds, and again, energy gets released. And so can you just have like hydrogens floating around in the cell? And the answer to that question is no, you can't. And so what winds up happening is you get this electron carrier molecule called NADH. And NADH is just going to come in and it's going to pick up this hydrogen. Okay? And we're going to see later on, we're going to be using this NADH for the electron transport chain. We're going to be using this for energy later. Okay, so in glycolysis, you are taking this molecule here, you are breaking it into 2 pyruvate molecules. So you get 2 pyruvate molecules, and you wind up getting 2 NADH molecules, and you also wind up getting 2 ATP molecules from this. Okay, these ATP molecules are, again, they're generated when you're breaking those bonds. You're taking the energy from breaking those bonds and you are phosphorylating an ADP. I'm not worried about that detail right now. What I want you to know is that you're taking this glucose, you are breaking it in half, and you're picking up these hydrogens and you're putting them onto this electron carrier here, NADH. Glycolysis, you can think of this as what are you bringing in? That says glucose, by the way. You're bringing in glucose. Where did you get the glucose from? You ate it. Your body absorbed it. And what are you getting out from this process? You're getting some ATP. Well, where is that ATP going to go? It's just going to be used. It's already in a form that your cell can use it to do stuff. And so you're just going to use that ATP. This NADH is going to go to the electron transport chain. Stick with me on this one. Please watch the next few videos. This will make sense. But we're going to use this ATP later on to generate a bunch, or we're going to use this NADH later on to generate a bunch more ATP. These pyruvate molecules are going to go to the mitochondria. They're going to the mitochondria. They're going to a similar place as these NADH, but the pyruvate molecules are going to go into the mitochondria to generate more ATP and to be used in the citric acid cycle. But if you had to know something about glycolysis, this would be it. You bring in glucose, you get out ATP, NADH, and pyruvate.